Hello friends and welcome to this video. In this video we are going to analyze the 2D truss problem using ANSYS 2020 mechanical APDL. Now let's consider this is a 3-bar truss problem which is subjected to the horizontal forces and vertical forces. It is fixed at one end and having the roller support at one node. The value of E is given as 200 GPa. The cross-sectional area is constant for all these three elements, that is 300 mm square. We need to find the nodal displacement, stresses and reaction forces at each nodal support. So by analytically we get the solutions as first we get the deformation, that is a displacement, U1 V1, U2 V2 and U3 V3. Here U denotes the axial deformations in x direction and V denotes the displacement in y direction. This 1, 2, 3 suffix denotes the node numbers. At this first node there is a fixed support, so we get the 0 displacement. At this node there is a roller support, means there is a restriction in y direction, so we will be get the V2 as a 0 and in x direction we will be get a 0.4 mm. At node number 3, we'll get the deformation as 0.7083 in x direction and minus 0.25 in y direction. Then also we have calculated the stresses. So stresses in element 1 is 100 Newton per mm square. In element 2 is minus 83.33 Newton per mm square. And in 3 is 83.33 Newton per mm square. And the reaction at the supports will be get as a minus 15,000 Newton in x direction at node number 1, minus 15,000 Newton at node number 1 in y direction, and at node number 2 in y direction the reaction is 25,000 Newton. So let's analyze these answers using the ANSYS 2020 R1 mechanical APDL. So press the start key and type APDL. Then we will get this mechanical APDL product launcher. Click on this and the ANSYS window will be get open within the few seconds. Now we will get this window, and here also we are able to set the working directory, give the job name. So job name is giving as a truss, and then click on this run icon. Now we will get this ANSYS window on your screen. So first we need to define the preferences, structural, click on OK. In preprocessor we have to define the element type. So click on add edit, add. The element is taken as a link for the truss element also. Click on OK, click close. Then material properties, material models. We are considering the problem is of structural, linear, elastic and isotropic in nature. The value of E is 200 GPa, so we are going to write as 2E5 in Newton per mm square. Poisson's ratio is 0.3. Then click on OK. Now we are having only a single material. If we are having the different material, then we can able to add the different material also. But for this problem we are only having the single material. So click on close. Then go for the sections. Click on link because we are defining the element type as a link. Click on add. Now here add the section ID as a 1. Click OK and define the area. So area is given as a 300 mm square and which is common for all elements. So we are going to only define the one area. So click on OK. Then click on modeling, create. Then we have to define the nodes in active CS. Now this window will be get open and then we need to define the node numbers. So first number will be 1 and its locations at XYZ will be a 0. So click on apply. Now for second node number, as you can see in the problem figure, node number 2 is located at 800 mm from the first node, that is at from origin in x direction, and node number 3 is located at 800 mm in x direction and 600 mm in y direction. So let's define these two nodes in ANSYS. Define node number as a 2 and its location in x direction as 800 mm. Click on apply. so it will be get created. Now define the node number as a 3. Its location in x direction is 800 and in y direction is 600. Now click on OK. So we'll be get these 3 nodes are defined. One is at origin, second and third. Now join these 3 nodes node numbers by using the elements. So click on elements, auto number and through nodes, because we are having only a single element and single cross sectional area. So pick node number 1 and node number 2, click on apply. Again pick node number 2 and 3, again apply, and node number 1 and node number 3, and now click on OK. If we having the different elements and different cross sectional area, then we need to change element and area by using clicking on the element attributes. So as we are having the common area and common element, so we are directly connected these all nodes with the elements. Now minimize this modeling and go for applying the loads. So click on loads, define load, apply structural displacement on nodes. As this first node is fixed, so click on this node, click on apply and click all degrees of freedom. OK. So this node will be get fixed, and at node number 2 there is a roller support. So click on again node, click on node number 2, then click on OK, and for roller support click on UY direction must be locked and X direction is free. Also uncheck this all degree of freedom, only in Y direction we need to lock the displacement. So click on OK, so it will be get locked. Now we need to apply the forces. Now let's apply the forces on each node. So as you can see in the figure, the forces are at node number 2 there is a force of 30,000 Newton in X direction, and at node number 3 the force of 20,000 Newton in X and 10,000 Newton in Y direction. So let's apply these forces. So select force movement on nodes, select this node number 2, click on apply. Now the force in X direction, so select Fx and apply the force as a 30,000 Newton. Then click on apply. Again pick this node number 3, click again apply. In X direction the force is 20,000 Newton. So click on apply. Again pick node number 3 because there is one another force in Y direction. Now click on OK. The force is in Y direction, so select Fy and apply the force in minus 10,000 Newton. So the force is in downward direction, so don't forget to apply the minus sign. So the value is 10,000 Newton. Now click on OK. So as you can see here, the forces and all the boundary conditions are get applied. Now let's solve this problem. So minimize these loads, click on solution, solve and current ls. So if you click on OK, you will get this message solution is done. Close this window. Now to see the results, click on general processor, plot results, deform shape, deform plus and deform, and click on OK. So you can see here the stress member in deform as well as undeformed shape. This blue color indicates the deformed shape and white color indicates the undeformed shape. And the maximum displacement is given by 0.7511 mm. And as we need to see the different results, that is the nodal displacement, reaction and stresses, so we need to click on list results. So before that, as we know that to get the stresses we need to define the element table. So first of all click on this element table, and to define the table, if you having the ANSYS 2020 version, then we need to apply one command in the command prompt, that is a set, last. But if you having any older version, then no need to apply these commands. You can directly click on element table, define table, click on add, select the last option, that is a by sequence number, select ls and then type 1. Click on OK. So this element table is get defined. Click this close, and now to see the different results we need to click on this list results, then click on nodal solution, then degree of freedom and displacement vector sum. Because the truss is a 2D element, so it get deformed in x direction as well as in y direction. So to see the both deformations, click on displacement vector sum, click on OK. So you will be get this deformation results. At node number 1, it is a fixed, so no displacement. At node number 2, in x direction the deformation is 0.4 and y direction 0. And at node number 3, in x direction 0.70 and y direction minus 0.25. So these results are same as we have calculated using the analytical method. So by analytically we get the same results: u1 v1 0, u2.4 v2 0, u3 0.70 and v3 minus 0.25. So you can observe here these are the same results. Now let's see the stresses. So for see the stresses, click on element table data, select LS1, click OK. So we will get this stresses in each element. So element number 100, element number 2 minus 83.33 and element number 3 83.33 Newton per mm square. So also these are the same results which we have calculated analytically. So these are the same stresses we get the analytically also. Now let's find the reaction. So remember this reaction at node number 1 in x direction and y direction, and at node number 2 in y direction. So let's find out the reaction in ANSYS. To get the reaction solution, click on reaction solution. Click on all structure force because we need to calculate in x direction as well as in y direction. Click on OK. So you will get these reactions also. So at node number 1 in x direction minus 50,000, at node number 1 in y direction minus 15,000, at node number 2 only in y direction 25,000. So this same result we will be get. So we will be get this displacement, stresses and reaction. So all the results we are getting same as the analytical results. Now close all this window. You can copy these files and save or take the print for your results. Now close all this window. We are going to plot the same results. So to plot the results, click on plot results, again contour plot, nodal solution, degree of freedom and again vector sum. Click on OK. We will be get the deformation plot. And this is again a color plot. So according to the color code, the values are shown here. The maximum value will be 0.7511 mm. Minimum value is 0 at the fixed end. Now again to see the stresses plot, click on element table, select this LS, click on OK. This is the stress plot of each element having the maximum value as a 100 Newton per mm square and minimum value is minus 83.33 Newton per mm square. Again it will shown by the color code symbol. So these values are shown here. Again if we want to see the animation, click on plot controls, animate, deform shape, then deform plus undeform, click on OK. So you can see here the deformation plot. You can change the speed also. So in this way we can analyze the 2D truss problem using ANSYS 2020 R1 mechanical APDL. So I hope you enjoyed this video. Now you can able to solve any type of the 2D truss problem having different load conditions, then different material conditions, as well as having the different cross-sectional area. Thank you for watching.